All right, we're on to our second video for 10.7. The last video we went over some of our regular geometric or trigonometric functions, sine, cosine, and tangent. Now we're going to look over inverse trig functions, the inverse trigonometric functions. So a trigonometric function has a rule given by a trig ratio. If you know the sine, cosine, or tangent of an acute angle, you can use the inverse of the trig function to find the measure of that angle. So well, basically what that's saying is if we know that the sine of A equals x, so whatever value x comes out to be, like 3/5 or 12/17, whatever that is, or if they give it as a decimal, so like 3/5 would actually come out to 0.6. If the sine of A equals x, then we can take the sine inverse of x to get the measure of angle A. So we could find the measure, like how many degrees that angle is, using sine inverse. Same thing, if cosine of A equals x, then the inverse cosine of x equals the measure of angle A. And lastly, again, if tangent of A equals x, then the inverse tangent of x equals the measure of A. So let's see how that looks. If we were told, if we already knew that the tangent of angle V came out to 0.8098, then what we'd have to type into our calculator would look something like this. The tangent inverse, of 0.8098. That would give us the degrees of V, how big angle V is. Now to do tangent inverse, it's usually like that second button or the shift button, and then click tangent. It should be right above tangent. There's a tangent inverse, or tangent to the -1 power. So tangent inverse, and then type in 0.8098. When you hit equals, it should come out to about, again, we are approximating to the nearest degree, so round it to the nearest degree here. V should be about 39 degrees. So if the tangent of V is this amount, then V was a 39-degree angle. Same thing, if the sine of U comes out to 0.3420, then U, that angle, should be the sine inverse of 0.3420. Typing that in and rounding to the nearest degree, we'd have U is about a 20-degree angle. And last one, if the cosine of W comes out to 0.9135, we would type that in as W equals cosine inverse of 0.9135, which means that W comes out to about 24 degrees. It's around a 24-degree angle. So if we need to find the measure of an indicated angle to the nearest degree, this is similar to finding a missing side given our angle and two sides, or one side. So if we're looking at this angle right here, this is the angle we want. 21 is a hypotenuse. It's across from the right angle. 18 is an adjacent because it's right next to it. It's not opposite. It's not across here. Using this angle, what trig ratio would give us an A and an H? Well, A and H go with cosine, the ca, C-A-H. So we would say that the cosine of our angle, we don't know how big it is, but the cosine of that angle comes out to 18/21, adjacent over hypotenuse. Here, here. So what we'd have to do to both sides of this equation to try to get this unknown alone, the angle all by itself, we would take the cosine inverse of both sides. Cosine inverse on both sides of this equation. Now this whole thing, this whole ratio is one number. So it's the cosine inverse of all of this. Now cosine inverse crosses out with cosine, so it's just our unknown value, our angle all alone. Our angle in degrees equals the cosine inverse of, and then in parentheses, 18/21. If you type that into your calculator, then it should come out to that this unknown angle is about 31 degrees. So without having to use a protractor, if we know this is a right triangle and we know this is 18 and 21, this has to be a 31-degree angle. We showed it, or we proved it, with trigonometry. We don't even have to measure. So let's go on to example 13. Again, we have another angle. We're not sure how big it is, but we know that here's a right triangle. So a Across from our angle is the opposite, that's 16. The leg that's right next to our angle is 31, that would be our adjacent. What trig ratio uses opposite and adjacent? That would be tangent, TOA, T-O-A. So the tangent of our unknown is going to be 16 over 31. How do we get rid of this tangent on this side? Well, we would do tangent inverse on both sides of the equation. So we'd get that our unknown variable, how big this angle is, how many degrees this angle is going to be equal to tangent inverse of, again in parentheses, make sure this is kind of considered one big number, 16 over 31, or 16/31. So when you type that all into your calculator, our unknown angle should come out to 27 degrees, or approximately, rounding to the nearest degree. So this is a 27-degree angle. On this example, again, we have our unknown angle. We're not sure how big it is. Across from it, 36 is our opposite. Right next to it, 77 is our adjacent. And across from the right angle is our hypotenuse, 85. Now, to solve this one out, we can actually pick. If we know all three of them, we can either do the sine of our unknown, we can do the cosine of our unknown, or we can do the tangent of our unknown. If it was sine of our unknown, we'd use opposite over hypotenuse, or 36 over 85. If it was the cosine of our unknown, ca, we would do a over h, or 77 over 85. If we wanted to do tangent of our unknown, tangent, toa, we would use opposite, 36, over adjacent, 77. So we can do any of these to solve it out correctly. If we picked sine, this one, we would have to do the sine inverse on both sides. So our angle would be the inverse sine of 36 over 85, so it would come out to about 25 degrees. If we did cosine, we'd have to do the cosine inverse on both sides. So our unknown angle equals cosine inverse of 77 over 85, which comes out to about 25 degrees. If we did tangent of our unknown angle, so we'd have to do tangent inverse on both sides. So our unknown angle equals the tangent inverse of 36 over 77. And again, that comes about to around 25 degrees. All of these happen to come out to 25 degrees because trigonometry works for any of these ratios. If this is a right triangle with these numbers, then it has to come out to be the same exact angle. It has to every time. So this angle has to be 25 degrees. How did we get it? Well, we could pick if we wanted to do sine, if we wanted to do cosine, or if we wanted to do tangent. On your homework, you don't have to do all three of these. Just pick one, whichever one you prefer, set it up, and solve it out for that one. All right, for our last example, we have a word problem. Now this problem says that the angle that a ramp forms with the ground is 25 degrees, and the height of the ramp is 6 feet. Find the length of the ramp to the nearest tenth. Now this problem is fairly real life because a lot of the times when they're trying to design ramps for wheelchairs, they can only have the angle be so high. Okay, so 25 degrees is like the maximum that an angle can be. You can't have it go any higher. If it was a smaller angle, we'd have to have a much longer ramp. So doing this will decrease the amount of wood we need for the ramp and still make it safe for wheelchairs to go up. So the first thing we want to do is draw a picture. This is what the ramp is going to look like. Now the ramp goes from the top all the way down to the ground. And we know that it makes a 25-degree angle right here with the ground, and that it's 6 feet high. We don't know how long it is on the ground here, and we don't know how long the ramp actually is. But we're essentially designing the ramp here, so we're figuring out how long we need the ramp to be so that it would reach 6 feet high and 25 degrees. So if we're looking at this angle, and we know 6 feet, and we know L, or at least that's what we're going to call the length of this ramp, L, well, 6 feet from our angle is the opposite. L is our hypotenuse, because it's across from our right angle. When you measure from the ground, when you measure a height, you measure straight up and down, so at a 90-degree angle. So we know our opposite, we know our hypotenuse, which means the trig ratio we're working with is sine. So after we draw our picture, we'd say that the sine of 25 degrees is the opposite over the hypotenuse, or 6 over L. Yet we don't know how long the ramp is, that's what we're trying to figure out. So we can either set it up as a proportion, put this over 1, and then cross multiply and divide, or we can just say if it's sine of 25 equals 6 over L, just multiply L on both sides, and at the end what you get is L times the sine of 25 equals 6. Now to get L alone, we divide both sides by the sine of 25. L equals 6 over the sine of 25. And again, make sure when you type this into your calculator, be safe. Put an extra set of parentheses there so it knows that it's 6 divided by all of this. And after you type it into your calculator and hit enter, it'll tell us that approximately to the nearest tenth of a foot, this should be 14.2 feet long. So we would need a ramp 14.2 feet long to make an angle of 25 degrees go 6 feet high. And that'll be it for this last 10.7 video.